Hey everyone, welcome to our lesson on integer exponents and exponent rules. Let's get started. When we talk about integers, remember we're referring to whole numbers or negative whole numbers or zero. So when you see integers as exponents, you may see any type of these. If we see a number raised to a positive integer, when we're finished and we are starting to simplify our answers, we can simply type that in the calculator or perform the operation in our heads. 3 to the 5th, I would type this in to simplify my answer. If I see a number raised to a negative integer, what I'm going to do is I'm going to move that to the opposite side of a fraction. Right now, this is not a fraction, this is a whole number. So I can think of it as 3 over 1. If I needed to move that to the opposite side of a fraction, I would move my 3 to the bottom, and now that power can become positive. A lot of mathematicians like for us to never leave negative exponents, so this is what we'll do to correct that if needed. Opposite side of a fraction. Alright, and if we see a number raised to the 0 power, you might be surprised to know that that is always going to be 1, not 0. And I'll explain that why to you in just a minute. Okay, let's go over some exponent rules when we are simplifying exponent problems. If you see that you have the same bases and that you're supposed to multiply those terms, the rule for that is to add your powers. So here I have x to the 3rd times x to the 4th, and my bases are the same. They're both x. So I need to add those powers to figure out what that answer should be. So the answer here is x to the 7th, since 4 plus 3 equals 7. Very simple. When we multiplied bases, we added the powers. So you might guess that when we divide the bases, we're going to subtract those powers. It's just the opposite. So if I see same bases, like I do here, see these x's that are being divided, I need to subtract those powers. So I've got 10 minus 8 equals 2, so 2 is going to be my new power on x. So the answer to this is x to the 2, x squared. Alright, you may come across another situation where you're raising a power to another power. I've got x to the 3rd to the power of 6. When you see that, we're going to need to multiply those numbers to get your new power. So 3 times 6 is 18, so our final answer here is x to the 18th. Okay, so let's practice what we've seen. Anything raised to the 0 power, remember we say it is 1. It doesn't matter if it's a number or a variable raised to that 0 power, or a whole group of things, it's still going to be 1. And the reason for that is because if you remember the subtraction division rule that we talked about earlier, let's say that we had the same variable raised to the 3rd divided by the same variable raised to the 3rd. If I followed my subtraction rule for division, this would be b to the 3 minus 3, which is b to the 0, which we said is 1. And the reason for that is because anything divided by itself is going to be 1. So that's why anything to the 0 power is always 1. Okay, do you remember what we said to do to fix negative powers? We've got a negative power down here on this x, so we don't ever want to leave them negative. We want to fix those, and the way to fix those, remember, is to move them to the opposite side of a fraction. So what I will do is move this x to the top, and now that power can become positive. And I really don't have to have my 1 underneath, since it's now a whole number. I can leave it as x to the 12th. Alright, we've got some more practice. Let's say that we are multiplying the same bases. So recall in your mind the rule for multiplying same bases, and that we're already given the answer. So we've got g to the 4th times g to some power needs to give us g to the 10th. So remember, the rule for multiplying same bases is to add the powers. So what we're going to have to think about is, what number would add to 4 to give me 10? When you think about it, you're going to arrive at 6. So the answer here would actually be 6. Don't forget that we're adding those powers, not multiplying. Alright, let's look down here at the bottom example. We have 5 to the 6 divided by 5 to some power, we're going to need to find, equals 5 to the 4th. So you're going to need to remember the rule for dividing same bases, which is to subtract the powers. So what number can we subtract from 6 to get 4? And the answer is 2. So that missing power on 5 should be a 2. Alright, practice continued because there's lots of exponent rules. I'm multiplying the same bases here. I've got 3 to the negative 7th times 3 to the negative 8. So again, we need to add our powers. So our answer here is going to be 3 to the power of whatever negative 7 plus negative 8 equals. And that is negative 15. But remember, we're not going to leave negative exponents. We're going to fix that so that they're always positive. So moving to the opposite side of a fraction, we will arrive here, 1 over 3 to the 15th. Very simple. Alright, one more example for practice. This group of things raised to the 4th power. Remember, if we see a power raised to another power, we are going to need to multiply those powers. So I'm going to carry this power of 4 to both items here. So I'm going to have 2 to the 4th, and then y to the, remember I'm going to do 5 times 4, 20th. So I can continue and simplify this 2 to the 4th in my calculator, or I can leave it both expressed to a power, and this will be my final answer. And this concludes our lesson on integer exponents.